A very good evening all. Welcome to problem solving session number 1 of Mechanics of Material. So I am Sharath, a PhD student from IIT Madras at Department of Civil Engineering. So you might have already watched the lectures in week 1. So here in this particular session we will focus on solving problems related to various concepts that you have seen. Okay, so basically you might have seen three of the topics in week 1. So first, a basic introduction to what a mechanics of materials is, and then introduction to vector algebra, and finally something related to indicial notation, right? So today we will mainly focus on these two problems from these two topics, the vector algebra and indicial notation. Right. I will start with vector algebra. So before going into problem, just let me quickly recap the things. So what do we mean by a vector here? The first letter or first word that comes into our mind when we say vector, right, is nothing but direction. We might have studied a scalar and a vector right from our 6th standard. We would have studied a scalar is a quantity which only has magnitude, whereas a vector is a quantity which has both magnitude as well as direction. Okay. So the same concept here, the vector can be represented in various format. A computer science engineer or a mathematician, a physician can represent vector in various format. Say let's say 1, 2, 3. I am writing in a row vector as a row vector. So this is a vector format, or I can write the same vector as a column. Right, 3 rows, 1 column. So this is also a vector representation, or I can simply tell in the form of a directed line segment, right? Directed line segment. So in this course of mechanics of material, what we are mainly going to focus, when we say a vector, we mean it is a directed line segment. Okay, so that's what we mean. Now few of the operations in vector. So first, addition of vectors. How to add two vectors? Addition of vectors. Suppose if we have a vector A in pointing this direction and vector B pointing in another direction like this. Now if I want to add these two vectors, what should I do? So we can use triangle law of addition or parallelogram law of addition. So it simply means you just place the vector. So this is number 1, vector number 1. Oh, sorry, I didn't wrote B here. So vector number 2, right? And the sum would be this one. So this is vector C, which is equal to A plus B, right? This we say triangle law of addition. Similarly, in parallelogram law of addition, it's the same. It's not going to give us the different answer. Like we represent these two vectors as the adjacent side of the parallelogram. Sorry, what is the color which I used? Yeah, for B it is this color. So we can represent B as this, as two adjacent side of the parallelogram. Now the resultant would be the diagonal passing in between these two. Suppose these two are two sides of the parallelogram. Let's complete the parallelogram. So this is the adjacent side, opposite side of vector A, and this is opposite side of vector B. So the diagonal would be something related. So this is same as the C vector, which is A plus B. Okay. So this is how we add two vectors. And moving on to subtraction, we do the same by reversing the sign of b. Okay, that's not a big deal. And how about multiplication of vectors? We say scalar multiplication. So scalar multiplication, I say I have a vector A, and I want to multiply this with k times A. So this vector will become, if suppose k is 2, this vector length will be doubled, right, k times A. If k is greater than 1, it will magnified, enlarged. If k is less than 1, it will be shortened, right. If it is more than 1, it is elongated. So this is all about scalar multiplication. And then we would have seen something related to dot product, right. So dot product of two vectors. Dot product of two vectors. What do we mean by dot product of two vectors? A dot B equal to, suppose if we have two vectors A and B, the dot product is given by magnitude of A, magnitude of B, and cosine of the angle between them. Say suppose assume these are those two vectors A and B, and they both have angle theta. So A dot B will be equal to magnitude of A, magnitude of B times cosine of the theta. Physically it means, say suppose I am projecting B onto the A. From here I am shooting a flashlight, so, okay, flashlight, and the B is projected onto the A. So on the A you will have B times cos theta. So A dot B will be mod A mod B cos theta. Similarly, we have a cross product of two vectors. What do we mean by cross product? How will we define cross product of two vectors? A cross B. So here A cross product is represented by this symbol in this course. So mod A mod B sin theta n cap. And a small difference to note, in the previous product it is a scalar, the answer is a scalar, whereas in this product the answer is a vector. Okay. And here if you want to get the geometrical meaning, the cross product of two vectors gives us, the magnitude of the cross product of two vectors gives us the area of the parallelogram. Okay, this parallelogram. And again we have box product, the final one, box product represented by box of ABC. This is A dot B cross C, or right, you can write. So this is actually the volume of the parallelepiped formed by ABC. If we have a parallelepiped whose adjacent sides are A, B and C, the volume will give us the box product. Okay. So these are some of the basics with related to vectors. So let's quickly move on to the question that we have. So you might have had an assignment question saying like suppose, let's take this as question number 1. Suppose if we have A vector is equal to 2Ex plus 4Ey plus 3Ez, okay, and another vector, say B vector, equal to 4Ex plus 6Ey plus 8Ez. So if you have these two vectors, this is given in the question. Now what we have to find? First subdivision asks us to find angle between A and B. So how will we find angle between A and B? So just now we have seen so suppose if we have A vector and B vector given by this, so angle between A and B, how will we find? So from the definition of dot product, we know A dot B is equal to mod A mod B cos theta. Okay. So the theta is the angle between A and B. Now if I want theta, so I will keep cos theta alone on one side. So cos theta will be equal to A dot B divided by mod A mod B. Okay. Now how will we find A dot B? A dot B is, we have 2Ex plus 4Ey plus 3Ez dotted with, so 2 times the component of Ex in A times the components of Ex in B plus 4 times 6 plus 3 times 8. Okay. So this is again given by 8 plus 24 plus 24. So 48 plus 8, 56. Okay. And now what is modulus of A? Modulus of A is given by root of 2 square plus 4 square plus 3 square. 2 square plus 4 square plus 3 square, which is 4 plus 16 plus 9. Okay. 25 root 29. What is modulus of B? 4 square plus 6 square plus 8 square. 4 square plus 6 square plus 8 square. This is equal to 16 plus 36 plus 64, which is 116. Okay. Now just substitute everything in the given formula. So finally we will get cos theta equal to 56 divided by root 29 root 116. So this is cos theta. Now if you want theta, cos inverse of 56 divided by root 29 root 116. Okay. Let's just take the calculator. So root of 29 times 116 and reciprocal of it times 56. So this we are getting cos inverse of 0.9655. Okay. So what is this cos inverse of? Inverse cosine calculator will be there. Inverse. Cos inverse of 0.9655. So it is 15.1 degrees. Okay. So this is the angle between those two vectors. Fine. Okay. So that's about the first problem. Second problem. So first problem we saw angle between A and B. In the second problem, let's see what is the question. So second problem, they are asking what is the length of the diagonal of the parallelogram whose sides are A and B. Length of diagonal of parallelogram whose sides are A and B. Okay. So first of all, what is the diagonal of the parallelogram whose sides will be A and B? If this is the sides, then the diagonal will be its sum, right? This is the diagonal, which is the sum of the A and two vectors. Let's draw it little more clear. So B vector, this is the opposite side of B, opposite side of A. So the diagonal will be given by the sum of, so this is, so C vector is equal to A vector plus B vector. Now just add these two vectors until, so when we add A plus B, A is 2EX plus 4EY plus 3EZ. So B is this. So when we add, we will get 6EX plus 10EY plus 11EZ. Okay. So this is the diagonal. Now the magnitude of this is given by 36 plus 100 plus 121, which is how much? 136 plus 121. 257 square root of 257 will be 16.03. Okay, this is the magnitude. And question number third part in first question, orientation of diagonal with respect to Ex, Ey and Ez direction. Orientation of this diagonal is C vector with respect to first, with respect to Ex, Ey and Ez. There are three subdivisions in this question. So orientation of C with respect to Ex and Ey and Ez. Orientation is nothing but the angle between those two. Now how will we find angle between two vectors? We have C vector here, which is 6Ex plus 10Ey plus 11Ez, and another, let's do one by one. So 6Ex plus 10Ey, we want to find the angle between these two vectors. Okay, this is one vector and another vector is first Ex. So same concept, cos theta equal to, let's say this is capital A vector, this is capital B vector. What is cos theta? A dot B by modulus of A modulus of B, right? So what is A dot B? Same procedure. So A dot B is 6 divided by modulus of A will be root of 6 square plus 10 square plus 11 square, and modulus of B is 1, square is 1, right? So this is equal to 6 divided by, again do we have this modulus? Yeah, 16.03. So this is equal to 6 divided by 16.03, which is 0.3743. Now theta will be equal to cos inverse of 0.3743. What it would be? Again, inverse calculator, 3743, 68 degree. Okay, 68 degrees. Now again another question, the second part of the thing is, find the orientation of C with respect to Ey, and again orientation of C with respect to Ez. Okay, just a minute. Yeah. So what we will do, like in the next subdivision, instead of b equal to ex, we are going to have ey, and the same going to repeat, right? So the idea is only how to find angle between these two vectors. Okay, that's all. Now let's move on to the D question of this. So D question asks us to find vector product of A and B. So how will we find the vector product of A and B? Mod A mod B sin theta n cap we saw, but there is another way. If we have vector in components, the A cross B, we will write the basis vector in the first row. So Ex, Ey, Ez, Ex, Ey, Ez in the first row. In the second row, we write the components of A vector, which is 2, 4 and 3. In the third row, we write the components of B vector, 4, 6 and 8. Okay. Right. Now, this is equal to Ex times, this is solving determinant, plus minus plus, Ex times 32 minus 18 minus Ey times 16 minus 12 plus Ez times 12 minus 16. This is equal to Ex times 10, 28, 14 minus Ey times 4 plus Ez times minus 4. So the answer is 14 Ex minus 4 Ey minus 4 Ez. Okay, this is vector product, and this vector product is actually perpendicular to both A and B. Suppose if A and B are in this plane, this paper, in this space I am writing, plane I am writing, the cross product now for this case will be coming out of the plane, this paper, this screen. Okay, this is A cross B. This A cross B is perpendicular to both A and B. Okay, this is one property that we all should know. Now moving on to the next question. The next question asks us, what is the component of unit vector? Component of unit vector that is perpendicular to the plane containing A and B along Ex direction. So the next question, we want to find what is the component of unit vector that is perpendicular to the plane containing A and B along Ex direction. So first of all, what is the unit vector that is perpendicular to both A and B? If A vector we have and B vector we have, what will be a vector which will be perpendicular to both A and B? It will be A cross B, right? So this A cross B will be the vector which will be perpendicular to both A and B. Just now we found A cross B is equal to 14 Ex minus 4 Ey minus 4 Ez. Now we need to find the component of the unit vector. So this A cross B, now it's not a unit vector. What do we mean by unit vector? Unit vector is a vector with magnitude 1. So here A cross B is not a unit vector. So we need to make this vector into a unit vector. How will we do? We will divide this with A cross B with the magnitude of A cross B. Okay, A cross B, right? Say suppose I have phi Ex is a vector. If I want to make it a unit vector, what will I do? I will divide with phi. So it will be 1 Ex. So simply here we have a vector. If I want to convert into a unit vector, simply what we will do? We will divide it with the magnitude of A cross B, right? So this is equal to 14 Ex minus 4 Ey minus 4 Ez divided by what is the magnitude of A cross B that we have to find. Okay. So square root of 14 square plus 4 square plus 4 square. So this is equal to 14 Ex. Can someone in the meeting find and tell me what is the magnitude of this A cross B? Can someone help? Root of 14 square plus 4 square plus 4 square. (196) plus 16 plus 16. Let me do 196 plus 32, root of 228, which is 15.01. So I'll erase this and write 15.01 directly. Now this will be plus or minus, because square root of 4 is plus or minus 2. So square root of this 228 is plus or minus 15.01, right? And we will divide this individually to get the. So here the question is, what is the component of unit vector that is along that is perpendicular to A and B, a plane containing A and B, along Ex direction. So along Ex direction, my component is this 14 divided by 15.01, right? Along Ey direction, my component is minus 4 divided by 15.01. By the way, we don't write sign here because we have plus or minus. There are two options possible. So we will do just 4 by 15.01. Okay. So the component of the answer for this question, which is the component along Ex, will be 14 by 15.01. Okay, this is the magnitude. And similarly, component along Ey will be 4 divided by 15.01, and component along Ez will be 4 divided by 15.01. Okay, this is the answer. Okay. Next question. I am just checking whatever I am speaking. Can people in this meeting, can you hear me properly, or are you facing any network issues from my side? You can put in chat or unmute and tell. It's just only we are here. Ravigiri Goswami or Nokni Konyak. I hope I am audible. Can someone just confirm or put it in chat? Okay, let's move on. So the next question is area of parallelogram whose sides are A and B. So we need to find question subdivision number H is area of parallelogram whose sides are A and B. How will we find for this? What will be the area of parallelogram whose sides are A and B? Is nothing but the modulus of A cross B. A cross B, right? Already we have found A cross B, and also we have the modulus of A cross B from the previous question. It is nothing but 15.01 square units, or it's a area, right? So fine. And next question, what will be the volume of the parallelepiped whose sides are volume of parallelepiped whose sides are A, B and A cross B. This is nothing but the box product. So box product of A, B and A cross B, A vector, B vector, A cross B vector is equal to, so box product again we will simply do using determinant. So first row is corresponding to the A vector components. So the A vector components is 2, 4, 3, 2, 4, 3, B vector components is 4, 6, 8 and A cross B vector components is 14, minus 4 and minus 4. 14, minus 4 and minus 4. Okay. So this solving this determinant will give us the box product volume of the parallelepiped. Okay, it's very easy. Let's do 2 times 6 4s are minus 24, minus 24 plus 32 minus 4 times minus 16 minus 16 18 14 8 112 minus 112. Please check like whatever I am doing it's correct, like there can be any silly mistake. If anything, please let me know on spot. So 3 times minus 16 minus 14 6 are 84. So 2 times 8 minus 4 times 112, 22 minus 1 28 and 3 times 84 94 100, right. So 16 plus 8 4s are 32, 8 4 2s are 8, 11 1s are 4, 5 and plus 300. So hope the calculations are going right. 4 times 128 plus 316. This is 828. 828 cubic units. Okay, because it's a volume. So volume is measured in cubic units. Okay, so that's it. Okay, suppose there is another term in your assignment, only these are the subdivision that you have to do. I will just repeat once again. So first angle between A and B. Angle between A and B is nothing but the one which we easily compute using the dot product, cos theta equal to A dot B, right, divided by mod A mod B. We can directly find. And length of the diagonal of the parallelogram whose sides are A and B. Here we need to know the parallelogram law of addition, right. If A and B are vectors and the diagonal which is passing through A and B will give us the the addition of these two vectors. Okay. And orientation of C with respect to again angle between two vectors, and then we saw what is vector product and how to find, and we also saw a property of vector product, that is the direction of A cross B is nothing but the direction which is perpendicular to both A and B. Okay. And we saw how to find a unit vector, and we saw the magnitude of A cross B is nothing but the area of parallelogram, and we saw finally the box product, the volume of a parallelepiped formed by three vectors are nothing but the box product. Okay. Fine. So this complete the first question. Next we will see some problems related to indicial notations. Indicial notations. Indicial notation. Actually, you might have thought we came for mechanics of materials, but what is the reason in the week 1 lectures we are going through the basics of mathematics and some notations which is not actually mechanics, like these questions can come, but what we are currently looking at is the alphabets of mechanics, like the big equations we can represent using simple notations. So this is this may be very new to most of you. So this is just a matter of writing using following a particular notation. Let me try to address it with some problems. So first, problems from repeated indices in sum. Okay. See, suppose if we have something like A11 x1 plus A12 x2 plus A13 x3. Suppose if we have this, or usually in lower classes we might have studied something called summation, right? A1 plus A2 plus A3. How will we write summation of I equal to 1 to 3 AI, correct? This is 3. I equal to 1 to 3 AI. So in indicial notation, what we do, we write the same thing, but we drop the summation symbol. So it is only AI. Okay, AI. Fine. So AI means it is coming from 1 to 2 to 3. Okay, and say suppose if we have something like AII xk, what does it mean? Here, when I is repeating twice, please listen carefully. When I is repeating twice, we need to sum it from 1 to 3. So it is like A11 xk plus A22 xk plus A33 xk, that's it. Okay. So when any index is repeating 2 times, it means we need to sum it from 1 to 3. Okay, that is the simple way of writing this in indicial notation. Okay, so let's go through some more problems. Say suppose if we have Aij xj, here what is repeating? What is the index which is repeating? Aij xj. J is repeating, correct. J is repeating twice. So which means what we have to do? We have to replace j with 1 to 3. So ai1 x1 plus ai2 x2 plus ai3 x3. Okay, that's it. Fine. So this is, instead of writing this big thing, we simply write the small thing, that's it. Okay, instead of writing using a big expression, 3 terms are there, but here we are simply writing using a single. This is also called as Einstein summation, Einstein summation convention. Okay, so this is about indicial notation. Next, we have to understand something called free index and dummy index. Free index, what do we mean by free index and what do we mean by dummy index, because it's important in indicial notation. I am again checking whatever I am speaking, can you people able to hear? Like if you can hear it properly, can you put it in chat, yes or no? If you can hear properly, just put yes, or else no, something, so that I will know that I am in sync with you. If you have any questions, please feel free to ask me. Okay, thanks Sri Keshava. Okay, thank you. So let's proceed. Free index and dummy index. We have, say, suppose I am giving your question. In the previous example which I showed you, A, I, J, X, J. Here there are 2 index. What are they? I and J. Okay. Here, if any index is repeating twice, 2 times, that index we call as dummy index. Dummy index. Okay, the word dummy means like you can replace it with any other alphabet for that matter. I can say this as A, I, K, X, K, doesn't matter. A, I, M, X, M, all are meaning the same. Okay, all are meaning the same. So this index which repeat itself twice is called as dummy index. Fine. And there is an index which is coming only one time, the I is here, that is called free index. This I is called free index. Okay. So dummy index you can change with various other alphabets. It's not going to happen anything, but this free index is not like that. Say for example, maybe let's see some example, you will understand. Suppose if you have a problem like expand, you have to expand yi is equal to air xr. Okay, air xr. So this is a question that we have to expand. In indicial notation, there is a big expression that we have consolidated into a small indicial notation expression. Now we want to again expand it back, right? How will we do with this problem? First, we need to identify what is my free index, what is my dummy index. What is my free index, what is my dummy index here? R is my dummy index. And one point to note, whatever I told, the free index, dummy index coming 2 times should be on the one side of the equal to sign. Right? I is also, you can say, sir, here I is also coming 2 times, but why you are not saying I as dummy index? Because I is coming only one time on the right hand side and another time on the left hand side. But the condition for dummy index is, it should come 2 times, or it should repeat 2 times on the same side, of the equal to sign. Okay, this is the equal to sign. This is the condition. So here, what is the dummy index? R is my dummy index and I is my free index. Right? So now if we have a dummy index, what we have to do? We have to write it from 1 to 3, sum it from 1 to 3. So yi equal to ai1 x1 plus ai2 x2 plus ai3 x3. Okay, so I am just writing this dummy index from 1 to 3. Now, if I equal to 1, it means y1 equal to a11 x1 plus a12 x2 plus a13 x3. If I equal to 2, it means y2 is equal to a12 x, is it 1 2? No, it is 2 1, right? 2 1 x1 plus a22 x2 plus a23 x3. And if I equal to 3, y3 equal to a31 x1 plus a32 x2 a33 x3. Okay, see this many equations using indicial notation we have written very simply, right? This big equation in a compact way we have written here. So this is the use of this indicial notation, right? In mechanics you will come across big equation, mathematical equations, differentiation, integration, everything we can represent using small notation. That is the power of this indicial notation. Okay. Now one question I have, so suppose is aij xj is equal to akj xj. Is it true? Is it true? Is aij xj is equal to akj xj? Can it be true or not? Just give an attempt. If it is true, just put true. If it is false, just put false in the chat. Is this expression true or false? Is the question. Can someone just make an attempt? Is both something I have written, is both are same or not? Is LHS is equal same as RHS or not? False. Correct? Right. So it's right. It's not true. The reason is here it is true only when I equal to k. It is true only when I equal to k. Otherwise it is not true, because my free index in the left hand side it is I, whereas in the right hand side my free index is k. Right? Free index we cannot change just like that, but dummy index we can change chumma using any alphabet. Okay. So this is again, this tells us the concept of free index and dummy index in indicial notation. Next, moving on, the third concept in the indicial notation, double sums. Double sums. Say suppose if I have we have to expand aij xi yj. Okay, so this is the expression that we have. What we need to do, we need to expand this. So how will we do? First, identify the free index, dummy index. So here look carefully, is there any dummy index? Yes, there are. What are they? It's nothing but I and j, because I is coming two times, and j also coming two times, right? So I have two dummy index. So what I need to do, I need to sum it up both, right? Let's do it. First we'll do one by one. Okay, in the beginning level, let's do one by one. I'll go with j first. I'll keep I as it is, so it becomes ai 1 xi. I am keeping as it is. Instead of j, I am summing it from 1 to 3. Okay, plus ai3 xi y3. Okay, I have done it. Now the one term became 3 term. Now each of these term again has a dummy index which is I. Now what I have to do? Again we have to write 3 times. So now let's write I also A11 x1 y1 plus A1 1 2 or 2 1. It is 2 1 because I is increasing. So A21 x2 y1 plus A31 x3 y1. Okay, this is this guy. Now plus again that guy will come A12 x1 y2 plus A22 x2 y2 plus A32 x3 y2. Okay, plus again the last guy will come I is my dummy index, so I am summing it from 1 to 3 1 3 x1 y3 plus A23 x2 y3 plus A33 x3 y3. Okay, that's it. So this is how we expand. See, there are how many 3 plus 3 plus 3 9 terms. These 9 terms using the indicial notation we have written just in one term, this one term. Okay, this big expression again we have consolidated into a very small expression. So that is again tells us the power of indicial notation. Okay, now let's move on. The most important concept in indicial notation is Kronecker delta. Kronecker delta. What do we mean by Kronecker delta? Say we are already seen what do we mean by dot product, right? Dot product of two vectors. Say suppose if we have a vector, okay, now having seen this summation convention, the indicial notation, suppose if I have a vector equal to a1 e1 vector plus a2 e2 vector plus a3 e3 vector. Okay, what is this e1 e2 e3? This is nothing but the ijk. In lower classes we would have studied using ijk, but here we will use e1 e2 e3 or ex ey ez as my basis. Okay, right. So if I have a vector like this, can someone tell how can I simplify this using Einstein summation, this indicial notation? How can I write this a vector using indicial notation? Can someone just try, make a try, unmute and try? Right or wrong doesn't matter, just try, it will be good if you can try. My question is simple, how can I write this a vector using this indicial notation? ai ei, right? Simply ai ei, fine. I is my dummy index. Now say I have another vector b, again b1 e1, basis won't change, b2 e2, b3 e3. If you have any question, you can stop me anytime, so please feel free to stop me if you are not understanding anything. So here I can write bi ei. Okay, I is my dummy index. Now what is this a dot b? What is a dot b? ai ei dotted with bi ei. bi ei. Oh no, why? Because we told it should be only 2 times. This index should not repeat more than 2 times. But here it's coming 4 times. So what we need to do? We need to change this index. So instead of bi ei, I am going to write bj ej. Okay, you can write anything you want. So I am going to change this to bj ej. Now what will happen? ai bi will come, ei dotted with ej. Okay, this ei dotted with ej is nothing but delta ij. I am representing this as delta ij. Okay, okay. So now tell me what is delta ij? Delta ij is what? Ei dotted with ej. Okay. What is dot product of two perpendicular vectors? If two vectors are perpendicular, what is the dot product? Quick. Any answers? We can use chat if you are feeling uncomfortable to use mic. You can use chat. What is the dot product of two vectors if they are perpendicular? Come on. If two vectors are perpendicular, the dot product is dash. We know A dot B equal to mod A mod B cos theta, right? If theta is 90 degree, what is cos 90? 0, right? If two vectors are perpendicular, the dot product is 0. Now, this E1, E2, E3 are orthonormal basis, which means they are mutually orthogonal. So, what is E1 dot E2? What is E1 dot E2? It will be 0, correct. What is E2 dot E3? 0. Fine. What is E1 dot E1? What is my E1 dot E1 or E2 dot E2? If two vectors are parallel, what will be the dot product?
1.
1. Excellent. So, 1. Fine. So, now let us move back. So, if I am asking what is delta 1 1? 1, right? What is delta 1 2? 0. Delta 3 1? 0. Delta 3 3? 1. If the index are same, then it is 1. So, we are defining delta ij as 0 if I not equal to j, as 1 if I equal to j. This is the definition of Kronecker delta. Okay. The symbol is called Kronecker delta. So, this comes from the definition of dot product of two vectors. Okay. Let's solve some problems. Suppose if you want to find what is already I have given delta 1 1, delta 1 2, say delta jj. How will we find delta jj? Just now we have seen free index, dummy index. Is there any dummy index? Yes, there is. J is my dummy index. So, what we have to do if we have dummy index? We have to sum it from 1 to 3, correct? So, it will become delta 1 1 plus delta 2 2 plus delta 3 3. And just now we have seen if I and j are same, then delta 1 1 will become 1, again 1 1. So, it will become 3. Okay. So, the answer is 3. One more question. So, we have to find delta ij aj. Okay. Let's do. If you have notebook, please do it yourself. You start doing, you can do along with me. So, it will be more effective, right? You can easily do this. So, what is delta ij aj? First ask, is there any dummy index? Yes, there is. J is my dummy index. So, what we have to do? We have to add from 1 to 3. A1 plus delta I2 A2 plus delta I3 A3, correct? Okay. Now, can someone think and tell what this first term will become? What is delta I1 A1? See, I am writing this alone, I1 A1. Suppose if I,
A1.
Yeah, please tell. Sri Keshava.
Delta 1 1, it will become 1.
1.
So, A1.
So, A1. So, for I equal to 1, it will become A1. For I equal to 2, it will become
0.
0. For I equal to 3, it will become again 0. So, only for I equal to 1, it will become 1. So, which is similarly here, this term for I equal to 2, it will become A2. So, I can simply write this as AI, is that right? The whole expression I can simply write it as AI. Okay. So this we say contraction property of Kronecker delta. See, you no need to do all these things. The first time maybe you can do, but later what you can do, see this index, you can just put it as AI. Suppose if I have, I will give one more question. Delta ij ai, this will become aj or ai. Which one? II is repeating, so just contract, put j, right? Or you can do as usual. The first few problems, better to write and expand and then understand. So let's go step by step. So I is my dummy index. So delta 1j a1, dummy index means what we have to do? We have to sum it from 1 to 3. So delta 2j a2 plus delta 3j a3. Okay, so I have written from 1 to 3. So this is equal to, now this expression only for j equal to 1, it will be 1, otherwise it's going to be 0, right? For j equal to 2 it's 0, j equal to 3 it's 0. So for j equal to 1, this entire expression will become what? This entire expression will become delta 11 a1 plus delta 21 a2 plus delta 31 a3, right? These two are 0. These two are 0 because Kronecker delta. This will become a1. Okay, for j equal to 1 it become a1. Now for j equal to 2, what will become? Delta 12 a1 plus delta 22 a2 plus delta 32 a3. Again these two will become 0. This will become 1, so it become a2. Here it a1. For j equal to 1 a1, j equal to 2 a2, j equal to j it's aj, right? So it is aj, not ai. Okay, so this is what I told before itself. Once you become well versed in the problem, no need to repeat every time this big steps. You can simply leave this index I and write aj. Okay, this is the answer. aj is the answer. Fine. If you have any questions, again please stop me and ask. Now moving on to the next problem. Delta ij delta jk, what will become? Delta ij delta jk, is there any dummy index? Yes, j, correct. J is my dummy index, so what we have to do? We have to sum it from 1 to 3. So delta I1 delta 1k plus delta I2 delta 2k plus delta I3 delta 3k. Okay, I have done it. Now let's do individually, like for I equal to 1, just think, for I equal to 1 what will happen? For I equal to 1, in this expression, the second term and third term will become 0. Let me write again, 1 1 delta 1k plus delta 1 2 delta 2k plus delta 1 3 delta 3k. Okay, these two is going to become 0. Only this will remain, which is delta 1k. Delta 1k. Okay. So next, for I equal to 2, what will happen? Delta 21 delta 1k plus delta 22 delta 2k plus delta 2 3 delta 3k. Okay. Now what will happen? Which one will remain? Which one will become 0? These
Delta 2 2 will remain.
delta 2 2 will remain. Delta 2 3 and 2 1 will become 0. Delta 2 2 is 1 again. So it will become delta 2k. Similarly, for I equal to 3, it will become delta 3k. Now I can simply write it as delta ik, correct? Delta ik. Okay. So this question, the answer to this question, delta ij, delta jk, is simply delta ik. Okay. Again, there is a trick here. You don't need to do all the steps. See, jj is repeating. So this is called contraction property of Kronecker delta. Okay. So Kronecker delta, if you have an index repeating like this, you can directly write, okay, this is a property, or you can just do yourself and you can find it out. Okay. Once you're done, no need to repeat it again. Let's do one more sum, last sum from Kronecker delta. Say suppose if we have delta ij, delta kj, cik. Okay. Delta ij, delta kj, cik. Okay. Try. What will happen? And one more property I have missed. This delta ij is equal to delta ji. This Kronecker delta, is it symmetric? Is delta ij is equal to delta ji? Is dot product commutative? A dot b, is it equal to b dot a?
Yeah, yes.
Yes. So we can write delta ij is same as delta ji. This is called symmetric property. Symmetric property of Kronecker delta. Okay, Kronecker delta is symmetry and also contraction property. Yeah, why I told? Because that we will use it here. So see, here we can do again from the beginning, because there are 3 dummy index. So we have to do it 3 plus 3 plus 3 times 9 terms will come. It will be a big expression. Okay, you can try it out. But since we have already learned this contraction property, we are going to directly use the property and do this sum. Delta ij, delta kj, I can write delta jk. Okay, cik. So here jj are coming in contraction. So after contraction, it will become delta ik ci k. Okay. Can we further simplify this expression? Again, let's try. What is the dummy index? I and k both are dummy index. So let's do one at a time. Delta, I am doing I, keeping k as it is. So say 1k plus delta 2k c2k plus delta 3k c3k. Okay. For k equal to 1, the second term, third term will become 0. It will become c11. For k equal to 2, the first term and third term will become 0. So it will become c22. For k equal to 3, again it will become c33. So what is this then? Can someone tell? Delta ik cik, delta ki cik, this can be written as ckk. Okay, that's it. So the answer to this question is ckk. Okay, because for k equal to 1, it's c11, k equal to c22. Again, here you can directly write, when we have a Kronecker delta, you can just use contraction property and do this. Okay, fine. So this is all about Kronecker delta. Last topic in indicial notation is permutation symbol. This is permutation symbol. Okay, so for Kronecker delta, we started with the dot product of two vectors. For permutation symbol, we will go with the cross product of two vectors. Say similarly, if I have a vector which is ai, ei, and b vector. Vector usually in lower classes we might have studied using upper bar, but in this course for consistency I will follow lower bar, okay, as a vector. 1 bar means vector equal to vj ej. Okay, I cannot use I again because I is already coming 2 times. There is a rule saying that only 2 times we have to repeat the dummy index. It should not come more than 2 times. So, what is A cross B? AI, EI cross BJ, EJ. So, AI, BI outside, EI cross EJ. What is EI cross EJ? EI cross EJ will be EK. Kronecker delta, permutation 1, 2, 3. Okay. Fine. So this, what is the meaning of this 1, 2, 3? This is equal to 1, or I'll write ijk since ijk. Okay. ijk is equal to 1 if ijk is coming in this cyclic direction, like if it is epsilon 1, 2, 3 or 2, 3, 1. Okay, 1, 2, 3 is coming in this clockwise rotation. If this is the case, then it is 1, 3, 1, 2. Okay, epsilon ijk is equal to minus 1 if it is coming in the anti-clockwise. ijk is there, but it's going reverse. 1, 2, 3 is there, but it's going reverse. Like epsilon 1, 3, 2, epsilon 3, 2, 1, epsilon 2, 1, 3. All these are minus 1. Okay. Now, what is epsilon 1, 1, 2? 0. Okay. Epsilon 2, 2. If any index is repeating twice, in this ijk is 0 if any 2 index are repeating twice. Okay. So, this is a new notation symbol that we have studied today, that is permutation symbol. So, this we use for cross product, and here like similar to Kronecker delta, if I and j are not equal, it is 0. If I and j are equal, it is 1. But whereas here, see, this is there, if 2 vectors are parallel, their dot product is 1. If 2 are perpendicular, their dot product is 0. Whereas here, this is cross product case. If it is coming in the clockwise direction 1, 2, 3, it is 1, because A cross B is equal to negative of B cross A. It is not commutative. So, it is going minus 1. Similarly, if we have any 2 index repeating 1, 1, 2 or 2, 2, 1 or 1, 1, 1, it is 0. Okay, this is a new term that we have studied. Okay. Now, let us do one small problem on this epsilon ijk, epsilon ijk. We have to solve this. What is this? We have to use again dummy index summation concept. How many free index, how many dummy index are there? 3 dummy index, I, j and k. I is coming 2 times, j is coming 2 times, k is coming 2 times. So let's expand it. So first I am going to expand I alone. 1 jk plus 2 jk plus 3 jk. Okay, done. Now in the first term again there are two dummy index j and k. Now in the first term I am going to expand j alone first. Let's do 1 k 1 k 1 2k I have to sum it up. Okay, epsilon 1 3k 1 3k. Okay, so this is first term alone. Now second term, let's write it here. So epsilon 2 1k epsilon 2 1k plus epsilon 2 2k epsilon 2 2k plus epsilon 2 3k epsilon 2 3k. Okay, finally third term. Let's keep writing. Plus epsilon 3 1k epsilon 3 1k plus epsilon 3 2k epsilon 3 2k plus epsilon 3 3k epsilon 3 3k. Okay, now no need to put k because it will go again 3 into 3 into 3, big number of expression. So what will happen to this first term? Epsilon 1 1k, can someone tell what will happen to epsilon 1 1k?
It will be 0.
It will be 0 because 1 is repeating one more time, so 0. How about the second term epsilon 1 2k? For k equal to 1 it becomes 0, for k equal to 2 it becomes 0, for k equal to 3 it becomes 1. Okay, so for k equal to 3 only it will become 1. So 1 plus again similarly for k equal to 1 it becomes 0. The third, I am at the third term, this third term. For k equal to 1 it became 0, for k equal to 2. What is for k equal to 2? Epsilon 1 3 2, it is 1 or minus 1? 1 2 3 1 3 2 is minus 1, right? Yeah, 1 3 2 is minus 1, but minus 1 into minus 1 will become again plus 1, so it will become plus 1. Okay, and how about the third? Yeah, third term done. Similarly here we will get 1 plus 1 and similarly 1 plus 1. So finally we will end up in 6. Okay, so epsilon ijk answer is 6. Fine. Right. So let's see maybe some examples, or still we have some 20 minutes to go. I'll cover the questions on representation of vectors. It's an important concept. So this is all about indicial notation. If you have any questions, you can put in chat or you can unmute and ask. So we are going to move to the final concept of the day. So first we have seen what is about vector algebra, how to solve problems in vector algebra, and next, like in vector algebra we saw addition of how to find angle using dot product, and how to find the length of the diagonal using concept of magnitude, and we saw the diagonal is the addition of two vectors. Then we saw again the concept of angle. Then we saw how to find vector product, and component of unit vector perpendicular to A and B, and we saw area of parallelogram and volume of parallelepiped, which is nothing but the cross product and the box product. Then we saw something called indicial notation. So indicial notation, we told if we have any two index repeating twice, it means summation from 1 to 3. So we saw what is free index, what is dummy index. Free index, we cannot change the index as like that. Dummy index, we can just play around, we can change the variables. And then we saw two important notations in indicial notation, the Kronecker delta and the permutation symbol. We saw delta ij becomes 0 if I is not equal to j, it becomes 1 if I equal to j. And similarly, in case of permutation symbol, we saw epsilon ijk become 0 when any two index are repeated. If it becomes 1 if it is in the cyclic rotation, if it is -1 if it is in the anti-cyclic anti-clockwise rotation. Okay, this is what we have seen. Let's come to the final topic of today's session, that is representation of vectors. Representation of vectors. So here we need to understand what do we mean by basis vector. So we know what is a vector, right? Vector is a directed line segment. A line segment is there. It is showing having some magnitude and some direction. So this we say a vector. This can be a velocity, it can be acceleration, it can be a force, it can be any mechanics quantity. Okay, so this is a vector. Now we can represent this vector. We can only represent this vector using some basis. Without basis, we cannot represent. So here I am taking the basis as Ex, Ey, Ez. Okay. So what do we mean by basis is that we need to have a condition such that, say, if this is a vector, a vector is written like Ax, Ex plus Ay, Ey and Az, Ez. It should span the entire three-dimensional space. Okay, using this Ex, Ey, Ez are qualified as basis. Okay, using this Ex, Ey, Ez, we can represent any vector A which can span through the entire three-dimensional space. Okay, if we can do that, then Ex, Ey, Ez are the basis. Now, if they are mutually orthogonal, then we call it as orthonormal basis. Orthonormal basis. In orthonormal basis, Ex dot Ey equal to 0, Ey dot Ez equal to 0 and Ez dot Ex equal to 0. Okay. Now, the thing is, suppose if I change this Cartesian coordinates, like if I change this basis from Ex, Ey, Ez to say Ex star, Ey star, I am rotating this theta. So this also will rotate by theta. Ey star and Ez star is as it is. So now what will happen? Will my vector A change? No, it won't change, but its component will change because this Ax, Ay, Az are the components in Ex, Ey, Ez basis. Now when I change this basis, everything will change. Okay, so it's like changing the coordinate axis itself. In this xyz, let's take xy alone. I have a vector like this. Say this is 2, this is 3. So this is 2i plus 3j, right? This is what we have studied. Here we will write this as 2ex plus 3ey. Okay. Now what will happen if I change this coordinate system? Like here it becomes x dash, y dash, y dash. Okay, this is theta, theta. rotation. Will it be same 2 ex dash 3 ui dash? No, no, it will be different because now my basis is changing. It's like changing the way of representation. Okay, so now our question here asks us, like, it gives us two relation between this x and x dash. So it asks us how to write the components of vector in another basis system. Okay, so if you have watched the lectures, you might have seen that the relation between one basis, say I am taking u star, is given by q transpose u, right? Okay, what is this q? This q is given by ei dotted with ej star. Okay, how this is coming? I request you to please go through the lectures. So there is a clear derivation, 15-20 minutes derivation of how this is coming. Okay, here I am just saying how to transform using this results. I am not deriving it from the first principles. Okay, say in the question, let's take a question directly. We have something like ex tilde equal to ex plus ey by 2, and ey tilde is equal to minus ey plus ez by 2, and ez tilde is equal to ez. Okay, see, these are all vectors, so that's why I am putting under bar here. So we have a relation between two coordinate system, ex, ey, ez, and ex tilde, ey tilde, and ez tilde. Now what we have to find, we have a vector also, u equal to, in terms of ex we have 3 ex plus 2 ey plus 3 ez. Now we have to find in terms of u tilde. In ex tilde basis, what is the component? What is the component? This is a question. In your assignment question also, the last part you might have encountered this question. Okay, so how to solve? Let's go ahead. So first, what do you have to do? Step 1 is form the transformation matrix. So before that, we know that u tilde is equal to q transpose times u. Okay, this is the vector. This is we know. Okay, now finding transformation matrix. Let's do step by step. Finding transformation matrix. First is the Q matrix. Finding transformation matrix. Matrix Q. Okay. Now what is this Q? Q is given by EI dotted with, this is a tensor. I am putting it on double bar here. The next week lecture, upcoming week lectures, you will be clear what is this double arrow means. EJ star. EJ star, or here it's tilde. So let's put EJ tilde. Okay. Now what is this Q? This is QIJ. Okay, component of Q. Let's put QIJ. Now what is Q11? First column, first row. E1 tilde. Okay, here it is in x, y, z. So it is Ex dotted with Ex tilde, in other words, right? Ex tilde. So what is this? Ex tilde is here. So dot product of that will be 1 by 2. Correct? I'll do clearly for 1. Then we will do. So Ex is Ex as it is, dotted with here Ex plus Ey by 2. Okay. So, this is equal to again Ex dotted with Ex is 1 by 2 is there, plus Ex dotted with Ey is 0. That is how it became 1 by 2, right. How about Q12, first row, second column? For this question, what is E1 dotted with E2? This is Ex Ey tilde. Ey tilde is here, Ex is not there, no? So, it is 0, correct? It is 0. What is Q13? E1 dotted with E3 tilde. Here in this question, Ex dotted with Ez tilde. Ez tilde is Ez dotted with Ex is what? 0. Fine. What is Q21? Q21 E2 dotted with E1 tilde. Okay. E2 is E2, E1 tilde is here, E2 is Ey, E1 tilde is what? Ex plus Ey by 2. So, this is equal to 1 by 2. What is Q22? E2 dotted with E2 tilde. Okay. So, E2 is Ey again. What is E2 tilde? E2 tilde is minus Ey plus Ez. Minus Ey plus Ez by 2, which is minus 1 by 2. What is Q32? Q32 is E3 dotted with E3 tilde. E3 is Ez. What is E3 tilde? E3 tilde is Ez, right? Is 1, right? No. There is a mistake, right?
Why didn't we take Q23?
Yeah, that's a mistake. Yeah, it should be 2, 3, correct. Thanks. It should be 2, 3, right? E2 dotted with E3 tilde. E2 is Ey, no, E2 is Ey, correct. Ey, E3 tilde is Ez, so this becomes 0, correct? Is this right now?
Yes.
Okay. Last row, Q31. What is Q31? E3 dotted with E1 tilde. E3 is here, Ez. And E1 tilde is what? E1 tilde is Ex plus Ey. Ex plus Ey by 2. It's 0, right? Because there is no Ez component. Q32 is E3 dotted with E2 tilde. So, Ez dotted with again, there is some Z is there, minus Ey plus Ez by 2. So, this will become 1 by 2. Final Q33 is E3 with E3 tilde. E3 is Ez. It is also Ez, na? So, this is 1. Okay. So, Q matrix is 1 by 2, no. Yeah, 1 by 2, 0, 0. 1 by 2 minus 1 by 2, 0. 0, 1 by 2, 1. Okay. And finally, let us substitute back into this equation, say 1. So, substituting Q in 1, we say U tilde one by 2 0 0 1 by 2 minus 1 by 2 0 0 1 by 2 1, and U is, they have given in the question, U is 1 2 and 3, 1 2 and 3, that's it. So when we multiply this, will become 1 by 2, this will become
I'm sorry to interrupt you, but isn't it like Q transpose U? Like, aren't you supposed to transpose it?
Exactly, I missed this. Thank you once again. Yeah, correct. So yeah, in the derivation we will get Q transpose into U or U transpose into Q. This we have to be clear, correct. So since we are writing matrix in the front, so it should be transpose. Thank you. Second row. Okay, so 1 by 2 plus 1, which is 1.5, 3 by 2, 0 minus 1 plus 3 by 2. 1.5 minus 1 is 0.5, and this is 0 plus 3. So the final answer is 1.5, 0.5, 3. Okay, the component in the x tilde direction is this is x tilde direction, this is y tilde direction component, this is z tilde. Okay, that's it. So this is how we will solve. Fine. So that's it. Finally, suppose if we want, suppose if they give the question in terms of, say, like this, if you have Ex star in terms of Ex and Ey something, I am just writing for example, Ey star Ez plus Ex something, Ez star equal to Ez. Now if suppose if they gave some V star, okay, in terms of X star direction, the rotation the new coordinate direction, basis direction, and they are asking you the reverse one, like same thing, V equal to what? So we know V star is equal to Q transpose V. Now if we can use this inverse to get the V transpose, and here it's important to know that this Q has a property, inherent property in it, that is Q transpose must be equal to I. It should be orthogonal, or the transpose and inverse are the same. It should be orthogonal. This is a condition. This we would have got in the derivation. Okay, this is the basic requirement for Q matrix. Matrix, if it want to be a transformational matrix, in case of linear transformation, then it should be a orthogonal matrix. Okay, any Q matrix you would have got should be an orthogonal matrix. Fine. So with this, we come to the end of this lecture or this problem solving thing. If you have any questions, please feel free to unmute and ask. I am seeing one question in the chat. I had a doubt in Kronecker delta. Can you please help me understand the significance of Kronecker delta? Gopika, can you
Okay,
elaborate your question?
yeah. Sir, actually, the vector part of the lecture, I am able to visualize it. Okay, there's a vector. It could be velocity or whatever. But when it comes to Kronecker delta, like A, I, J, K, I'm not able to find the significance between that and I mean, why do you have to learn that? Like, I mean, uh, I kind of feel it's like some mathematical puzzle. I'm not able to visualize why we need it. Like,
Okay,
are you
maybe
getting
I'll
my
try.
point?
Yeah, yeah. I'll try my best to explain at this point. We also asked the same question, like when we entered this course in here, like it was totally out of syllabus kind of, because we came to learn mechanics of materials, which deals with stress, strain, Young's modulus, shear force, bending moment. But what is the need to understand this Kronecker delta, permutation symbol, all those stuff? Because of just a single reason. Stress, the stress and strain are the basics of mechanics, right? We would have seen in the video, introduction video, the four concepts. So force and displacements we cannot relate directly. So we will relate through stress and strain using a constitutive relation. But what is a stress? It's a tensor quantity. Now, what do we mean by tensor? You will see in the next week lecture. Tensor. So we have seen vector. Vector is having a single direction and magnitude, like a1, right? E1, a1i ei plus a2 e2 plus a3 e3. So this is a vector. Now, if you come to stress, it is a tensor, which means you need two, like if I take a stress block, all these things you will see in detail. It is sigma 1 1 and sigma 1 2, like in each plane it will change. Okay, stress is a physical quantity which is a tensor quantity. It's not a vector. So since this mechanics of materials is totally related with tensor, stress tensor, so we need to know the tensor algebra, tensor calculus, the basics of tensor. Tensors, it's difficult for us to write a big expression. So indicial notation are simply a language where we use to represent big expression shortly. That's it. There is not much physical interpretation or significance as to my knowledge. Maybe if there is something, I'll surely let you know in the next lecture, live session. But as per what I have seen, all these indicial notation we will use to write a big expression, big equation in terms of small compact representation, just a representation of things. There is no big physical meaning hidden behind.
Okay, thank you, sir. And sir, one more doubt I had. It
Sure.
was regarding the dummy index and free index.
Yeah.
Like ultimately we are summing everything, like I, even if there are two i's or two j's, ultimately we are summing it to three, like up to three.
Yeah.
So what is the difference, like other
No.
than they are repeating?
Free index we don't sum it up, right? Only dummy index we sum the. For example,
Yeah, okay.
dummy index we sum. That's the rules of indicial notation. This is like we have rules you have to follow, like this should come here, this should come here, like that. So first rule number 1 is if index is coming twice, you sum it from 1 to 3. And rule number 2 is index cannot come more than 2 times. So these are two major rules. And yeah, free index we cannot interchange. Dummy index we can
Like sir,
interchange. So these are the basic rules that we have to follow.
Sir, in this problem that you're displaying now, J is the dummy index, right?
Yeah, J is the dummy index, correct.
Yeah, we are summing it, I mean, to 1, 2, 3.
Yes.
But I is we are summing up I also, like I
No,
equal
no.
to 1, I equal to 2, I equal
No,
to 3.
no, that we are not summing up. It stopped it till here. Suppose if I equal to 1, I just explained as a case. If suppose I is 1, it is delta 1k. If I is 2,
Okay.
it's delta 2k. But here the finally it's I is I, so it's delta ik.
Oh, okay, okay, okay.
Okay, this is just
Oh,
to
okay.
explain.
And the reason why we are always summing it up to 3 is because it's a 3D space that we are
3D
using.
space. But usually it is n dimensional, but here mostly we see only 3D, so that's why 3D space.
Okay, okay, so yeah. Okay, thank you.
Thank you. Any other question from Sri Keshava?
No, sir.
No. I'll just once again I'll stop this recording and just let